Here we are, College Algebra, section 7.3. We're now going to learn how to do matrix operations. So the things we're going to do today is add and subtract matrices and how to multiply a matrix by a constant, or also how to multiply matrices together. And the beginning of this is pretty simple operations, and then when we learn to multiply matrices, that's a little bit of a trick. So just to prepare you, get ready for that one. Matrix addition is very simple. The key to this is you have to have the same dimensions. If you don't have the same dimensions, if you don't have a 2x3 and a 2x3, then you can't add them together. They have to match, because when you add, you just add the matching parts. So the top left plus the top left, that would just be A plus W, whatever that is, and that will be your new top left of your matrix. Top right plus top right would be your top right, and then C plus X and D plus C. So whatever is in the corresponding spot would be added. So like this is position A1, 1, A row 1, column 2, A row 2, column 1, A row 2, column 2. This is B1, 1. So because this is 1, 1 and 1, 1 in position 1, 1, you can add them together. So this one is a 3 rows by 4 columns. So we have a 3x4 and a 3x4. So that means we can go ahead and add, and we're just going to add up corresponding parts. We're going to end up with a 3x4. So 1 plus -1 is 0. I'm going to go across the rows. So 3 plus 4 is 7. And just notice we are adding here. -8 plus 2 is -6. 0 plus 4 is 4. And then I'm going to move down. 3 plus 5. 6 plus -2, 1 plus 4, -3 plus 2, -4 plus -5, moving down again, and 5 plus 1, 3 plus 4, and 2 plus -1. So just be careful with your positives and negatives and all that stuff. But adding is fairly simple. You just add corresponding parts. Look out for that sign in the middle, because sometimes they will change that to be a subtraction. Find the following sums of matrices. Sometimes they'll just word it a little bit differently. So it says A, this is matrix B, and we want to do A plus B. They may not show you this step, but that's what you're doing. So what happens when we add these two matrices together? 2 and -2, 3 and -3, 1 and -1, and 4 and -4. We end up with 0, 0, 0, 0. That's called the zero matrix because everything's zeros. Not entirely exciting or anything, but it can happen. It's not very useful, really. Subtraction is exactly the same. They have to have the same dimensions, and you're going to subtract corresponding elements. So because there are so many numbers involved, I highly recommend adding the opposite, or add a line, change the sign, as you may have been taught. You're going to change all the signs. So because this is subtraction here, I would change it to addition and then change all of the signs of this entire thing, and then go ahead and add them just like the previous problems. So if you don't do that, and sometimes you forget that you're doing 2 minus 1 and -1 minus 2 and so forth. So for me, it's just a lot easier to keep track if I go ahead and make all those symbols. And then I can just go 3 plus -4 and so on. So I'll just finish this out so you have the answer. If you want to pause the video and try to do the next problem, or this one before I do, that would be awesome. And hopefully I didn't make any mistakes, but I believe that's what we've got there. All right, so the bottom one, there's just 3 things going on here. Like I said, if you want to pause the video and answer it, go ahead. I personally would add a line. I'm subtracting only this matrix, so I'm going to change all of these signs. And then we're also adding this matrix. So when I go to do this, I'm going to take the first term plus the first term here plus the first term here. So I'm just going to keep adding all of them. Since I've changed those signs, I don't need to worry about subtracting this one and adding this one because I've already taken care of that. So 1 plus 5 plus 2 is 8. And 4 minus 2 plus 3 is 5. And it's going to be a 3x2, 3x2, 3x2. So my answer is going to be a 3x2. This one's going to add up to -4. That's 1. And minus 8 is -7. That is -14 plus 2 is -12. and then that is -2. So there's our final answer for the bottom one, if you want to check that. So that's adding and subtracting, pretty much just whatever's in the right spot. Next, we're going to multiply a matrix by a real number. So this is called scalar multiplication, or just multiplying a number in the front of the matrix. Usually we put it in the front. They're calling it C, but it can be whatever number. So here's our problem. We have, this table contains the purchase prices and delivery costs for plywood, siding, and lumber. The supplier announces a 5% increase in all of these prices and delivery costs. So we have purchase price. So basically everything is going up 5%. So what do we need to do? We need to take every single thing. We'll just pretend like this is a matrix right here. And we need to multiply it by, well, if we're going to increase by 5%, we're going to multiply it by 1.05 to give its current value plus the 5%. So 100% plus the 5% increase is 1.05. Now, when we do multiplication, we usually put that in the front. So I believe on this page right here, you'll see the 1.05 is in the front of my matrix. And then we just multiply those in there. So I'm just going to use my calculator to help this go a little bit faster. Multiply each of those values, and I will have a new cost matrix for all of these products. And if I put it back in that table, I would have like how much it was to buy or deliver each item. 2.6 times 1.05, 273. And we're talking about money here, so if you do happen to get any decimals that are further out, you would round to the penny. 1 times 1.05, I don't need a calculator for that one. All right, as long as I typed these in right, we should have these new values. So with a 5% increase, these would be the new amounts that I would be charging. So you can see scalar, I should go back 1 second. You can see scalar multiplication. All you do is you take this thing out here and you're basically distributing it times every single piece inside. Now, multiplication of a matrix times a matrix is a whole different thing. So in order to multiply a matrix by a matrix, we're going to start out with just a row matrix and a column matrix. A row matrix is just a matrix that only has one row, and then a column matrix only has one column. So in order to do this, I wish you could see my hand, but I take this one and I tip it up. So what's going to happen is the A1 is going to go with B1, A2 with B2, and so forth, all the way to the last one. And when you do that, you multiply these together, multiply, 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 and then you add them all up. And your answer is going to be one single number. Because this was a one row and this one only had one column, we're going to end up with one answer. So all these numbers get added up. All right, so let's see what that looks like. I think there's one. Nope, there's not a 1 by 1. So that's how you do it when there's even more rows and columns. So if you have an n by n matrix, in order to multiply it, it has to be n by k. So the number of columns of the first matrix has to match with the number of rows in the second matrix. And that's because we're going to do that thing where we tip them up. And so when I tip up this, the number of columns needs to match the number of rows. You'll see when I actually do it, it makes a little bit more sense. I'm going to try to use colors to help you out. So we're going to compute AB and B times A for these two matrices. So here's AB. So I'm going to take the first row and the first column, and I'm going to tip this up so that 1 times A and 2 times C. 1 times A and 2 times C, and then we're going to add those together, and that's my first term. So I did that in red. That's going to be my top left. Now I'm going to move over. So I still am going to use the same first row, but I'm going to use the second column. So when I tip that up, I'm going to get 1 times B and 2 times D. 1 times B and 2 times D. And I have to add those two up. If they were numbers, I would just get like a single number there. So that was the top left for red. and the top right for blue. And that's how I knew where to put my numbers. Put my red one in the top left, I put my blue one in the top right. And now, since I'm going to move down to the next row, I'm going to move down when I write my answer. So I'm going to do the bottom row, the left side, and I'm going to put it in the bottom left. When I do that, I tip this up, so 3 times A and 4 times C. 3A plus 4C. Okay, and then last one, I need to do the bottom right. So I'm going to take the bottom row, right-hand column, and tip that up. So 3B and 4D. And we always add those terms and then have one answer. So if A, B, C, D were numbers, we would get 4 numbers here, and we'd have it. This is a 2 by 2. So we have a 2 by 2 times a 2 by 2. We ended up with a 2 by 2. All right, let's do that again to see what happens when we do B times A. So A times B versus B times A. Same order. We're going to do B, AB times 1, 3. So when we tip that up, we get 1A plus 3B. Okay. Top right, I always do it in this order. Row, doesn't really matter as long as you keep track and do them all. It's kind of like distributing. Row times column, row times column. This one would be 2A and 4B. And this is addition, so it doesn't actually matter which one you put first here either. But all right, moving on down to the next row. So moving down and first. So that's 1C and 3D. And of course, you don't need the ones either. That's just to show you that I'm multiplying them. So second row, second column, 2C, 4D. Now, the point of doing A times B and B times A is just to show you that these are not the same. So what that means is that matrices are not commutative. When you multiply, you don't get the same answer. Addition is commutative. If I do 2 plus 3 and 3 plus 2, I get the same answer. But with matrices, if I do matrix A times matrix B, oh, that's supposed to be a B. That does not equal matrix B times matrix A. Not guaranteed anyway. It can occasionally happen, but it is not guaranteed like that. We know that's a rule in addition. Okay, so that was a 2 by 2 example. You can also do bigger dimensions. In order to do it though, they have to have rows, the column row thing matching. So I always go, let's see, M times N, and they did N times K. So these two have to match, and your result will be an M by K. Because if you do it a few times, you'll kind of see the columns go away and the rows go away, and you end up with the outer. So that little writing out the dimensions can help sometimes. All right, here's an application problem. So we're going to read it and see what we need to do with these numbers. So a business plans to use 3 methods of advertising: newspapers, radio, and cable TV, in each of its 2 markets, 1 and 2. The cost per ad type in each market is given by matrix A. The business has 3 target groups, teenagers, single women, and men aged 35 to 50. Matrix B gives the number of ads per week directed at each of these groups. Does A times B or B times A give the matrix that represents the cost of ads for each target group in each market? So here's the deal. What did I say? I said we have to have the number of columns matching the number of rows. So let's name these matrices by their dimensions. How many is this? This is a 3 by 2. And this one over here is a 3 by 3. So A times B, this does not match this. So A times B is actually not going to work, and I'll show you that in a little bit. But if I flipped them around and I put the B in the front and I did a 3 by 3 first, then the 3 here and the 3 here would match. So it's going to have to be B times A. So I'm going to have to take the ads times the market, or the groups times the market. All right, so we need to find that matrix, and then we'll answer the question, what group of people is the most money spent on advertising? Because that will be in there. So here we go. To find the multiplication, I think this is on the next page. Let me check. Yep, we're going to multiply this out. So I'm going to show you step by step. The B is first. Here's my B, 3 rows, 3 columns. So it's a 3 by 3, and this is a 3 by 2. So I can do it, and my answer will be a 3 by 2 because those are the outside pieces. All right, here we go. If we are multiplying top and left, you multiply these numbers. So 3 times 12, that's my 36. 12 times 10, 15 times 5, and then you add those all up and you put 231 in your matrix. You don't have to show this step. This step just shows how that number came to be. Because so sometimes if you look at this and you look at this, you're like, how in the world did we get to 231 from this? So it's the first term times the top, middles, multiply the ends, and then add them all up. All right. So let's pick another color, and I like to stick with the same row and move to the next column. So I would do 3 times 10 is 30, 12 times 8, and 15 times 9. Add those all up, and you get 261. All right. Moving down, second row, go back to the first column and multiply those out, and you get this term. And then multiply, I'm not sure if I'm going to have enough colors to do all this, but second row, second column is going to be this one. Top, middle, bottom, add 268. Okay, and then let's try moving down and left. Top, middle, bottom, multiply, and add them all up. And one more. The top is 10 times 10, 11 times 8, 6 times 9, add those up. Okay, so that's how you multiply matrices. It's obviously a lot of steps. You would want a calculator probably to help you do that part a little bit faster. And now we can answer the final question, which was, which group is the most money spent? So just look at which number is the highest. And that's the 270. And so if you look at market 1 single females, and it's really close in market 2. So both markets are really focusing on the single females, it looks like. That's how much money is spent on advertising. So instead of having to look at those two big functions that they gave us at the beginning and try to figure that out, we could multiply them together and make it a lot easier to answer that question. So multiplication of matrices can be helpful. We can also use this in the calculator. So to do it, we would put matrix A in matrix A. So you go to matrix, which is second x to the negative 1, and then edit matrix A, and you would make it a 3 by 2 and put in matrix B. This is a new problem. So matrix B is a 4 by 3. Okay. And put that one in. So go ahead and pause the video and do that if you like. Do that now. If you do that, and you don't have to do this step, but basically if you just press matrix A, names, matrix A, and press enter, it will show you what you had in there, and it should match what we've got up here in matrix B. So what they wanted to do is compute B times A. So now you just have to do B A. If you put a time symbol in there, that's fine, but not required. And it will spit out the answer. There it is. Notice that this is a 3 by 2 and a 4 by 3. And if we do B times A, we're doing a 4 by 3, and A was a 3 by 2. These match, so my answer is a 4 by 2. So my little dimensions work out. Now what happens if I do A times B? So since you already have it in your calculator, go ahead and get the names in your working screen there to say A times B. Press enter, and you should get an error, because what are we doing? We're doing a 3 by 2 and a 4 by 3, and these do not match. So guess what? It even tells you that. The dimensions mismatch. So you can't do that. It's just not possible. And that's what you would write. If this comes up on homework, you just write not possible. All right. New question. This is about the identity matrix. I mentioned this a little bit in lesson 7.2, but the identity matrix is always the matrix with 1s and 0s. So it has to be a square, 2 by 2, or 3 by 3 would have 1s down the diagonal and 0s everywhere else. Okay, so the identity matrix is all full of 0s and 1s. It says write the 2 by 2 identity matrix. Well, I just did that for you. It's 1, 0, 0, 1. Usually read them left to right. For the matrix A, find IA and AI. So for part B, I'm going to multiply I times A, and I'm also going to do A times I. There we go. So we're going to do these two different multiplications and just see what happens. Now you could put them in your calculator as matrix A and B, or call them whatever letters you want, and then just multiply them both ways. But this one's pretty quick. Let's try it out. What do you get when you multiply the first row times the first column? You get 3 plus 0, because we're multiplying those first two and the second two. And 3 plus 0 is 3. Now I'm going to move over to the right. First row times second column is -2 plus 0. Okay, now I'm going to move down, and this time I'm going to get 0 for the first term and 1 times -1. And then I'm going to move to the right again, and I get 0 and 5. Now notice, what did I get for an answer? This is matrix A. It didn't change anything. So that's what an identity actually is what happens when you don't change anything. So like in basic math, if I do 3 times 1, what do I get? 3. So 1 is called the multiplicative identity. If I do 5 plus 0, what do I get? 5. So 0 is called the additive identity. And since we are kind of multiplying and adding, there's lots of 1s and 0s in a matrix. Same thing is actually going to happen here. When we multiply this row times this column, we're going to get 3 plus 0, which is 3. We're going to get 0 plus -2. And then when we move down, we're going to get -1 plus 0 and 0 plus 5. So we actually get the same thing both ways, which is, earlier I said it doesn't very often make it commutable. When you multiply I times A times I, it will be the same because I is the identity matrix. That's one of the only times that this happens. And that concludes lesson 7.3. So make sure you show a little bit of work there on your multiplying. Don't do everything on the calculator. Do the ones with small numbers on your own. Have a great day.